Example 9.5 is another application problem. Let's read through what we have. It says a certain brand of razor blades comes in packages of 6, 12, and 24 blades, costing $2, $3, and $4 per package, respectively. So when it says the word respectively there, what they're describing is that the 6 packs are going to be associated with the $2 cost, the 12 packs will be associated with the $3 cost, and then the 24 packs will be associated with the $4 cost. And the crossing of all these lines is a little unnerving to me, so we'll erase those. Then it says a store sold 12 packages. They sold 12 packages containing a total of 162 razor blades, and they took in $35. Seems important. I'm not going to try to digest all that right at the moment. My immediate concern is, what am I trying to find? So then it says how many packages of each type were sold. How many of each type were sold? How many? So as we look back at the narrative, it talks about there are packages of 6, 12, and 24. So there are 3 different types of packaging that we have here for the razor blades. That's 3 unknowns. That's going to be 3 variables for us. So I'm going to let X represent the first variable, and I want X to be associated with the 6 packs. Now, just like on the other examples, if all you do is say X equals 6 packs, then you've really not understood exactly what X is supposed to represent. X does not represent a 6-pack. You can't actually take a 6-pack and plug it into your equation, because that's what we're claiming X is supposed to be. So X has to represent not just the 6-pack, but it has to represent how many of the 6 packs were sold. So X represents the number of 6 packs sold. So we want to be as specific as we can with our variable, so that way it makes sense with our equation. Our equations, we're going to write 3. So Y is going to represent the number of 12 packs that are sold, and then Z is going to represent the number of 24 packs that are sold. So there's our 3 variables. We need to have 3 equations to go with that. And we look back to the narrative. Certain brand of razor blades comes in packages of 6, 12, and 24. We've got that. Costing $2, $3, and $4 per package, respectively. So if X represents the number of 6 packs sold, then I should be able to take X and multiply it by its cost. That would tell me the total cost from selling, or really the total amount of money that was taken in from selling the 6 packs. I could do the same thing for the 12 packs, which are $3 per package, so 3 times the number of packages. And then same thing for the 24 packs, I'll have 4 times Z. And then we have information underlined that I'll box in now that says took in $35. So I know that the total from all of the 6-pack, 12-pack, and 24-pack sales should be $35. That should be the total. So we have this one equation here that is built around the idea of cost slash price. Then I read a little bit further. It says a store sold 12 packages. Now that doesn't mean that they were all 6 packs or 12 packs or 24 packs. That just means the total number of packages is 12. Well, X represents the number of 6 packs, Y represents the number of 12 packs, and Z represents the number of 24 packs. So if I add all of these packages together, that should give me the grand total of 12 packages sold. So there is a equation here based off of the number of packages, which is a good thing because that's one of the things that we're looking for. It is the thing we're looking for. It's the number of each type of package that's been sold. And then the last equation is going to come from the information that we have 162 razor blades in total that were sold. So every time I sell a 6-pack, that means 6 razor blades are actually being sold, but they're all contained within that one package. So I have to take the number of 6-packs that I sell, multiply it by 6, and that will give me the total razor blades that are sold through 6-pack sales. Then I can do the same thing with 12 times Y, and also the same thing with 24 times Z, giving me a grand total of 162 razor blades. So this gives us an equation based on the number of blades that were sold, not just the number of packages that were sold. So there's your system. All 3 equations going with our 3 variables. This one is not going to need any rewriting. It looks like things are relatively nice already. You could do an elimination step, a substitution step, whatever you need to do to get this reduced to 2 equations with just 2 variables. So just like with example 9.4, I'm not going to take you through that entire solving process. It's a lengthy process, and the goal here for this example was really to show you how to set up the system. So I'll leave it as an exercise for you to go through and solve using the techniques that we learned earlier in the section, and also those from section 8. But I will give you the result. You should eventually calculate that x is equal to 5, y is equal to 3, and that z is equal to 4. And you would want to take the results here and write them as a sentence to be able to answer the question, and of course have the support work to support the claim that you have here for x, y, and z.